Jai Hind to all. My name is Manoj Kumar, Assistant Professor, Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. Today, in this video lecture, we will learn about the basic overview of data structures and its classification. It means different types of data structure. So, what is data structure? Actually, data structure is basically used to store the data element and to perform different kinds of operation on that data element. So, it is a way of organizing the data element. It may be the integer type of data, it may be decimal type of data, or it may be the character type of data. So, data structure is a way of organizing all the data items that are considered not only the element but stored also their relationship to each other. It means in context to the storage, what is the relationship between those data elements, or how those data elements are stored in different types of data structure. Basically, data structure is generally we use whenever we write a program, whenever we develop some kind of project, then we use different type of data structure like array, linked list, stack, queue. These are some type of data structure which are used during the program. So, whenever we write a particular program, then for that particular program to run or to execute that particular program, we need two things. First thing is the algorithm. Algorithm basically represent a step by step process to solve a particular problem. So, what is the algorithm? And after that algorithm, we need some kind of data structure in order to implement that algorithm. So, algorithm plus data structure, that basically form a program. Okay. So, to develop a program of an algorithm, we should select an appropriate data structure, whether the array is suitable or whether the queue is suitable. It depends on the application, or it depends on the objective to achieve which we are going to develop a particular program. Okay. So, by keep in mind the application or objective, we have to select an appropriate data structure according to the objective. Now, classification. Overall, data structure can be classified in two ways. First one is the primitive data structure and second one is the non-primitive data structure. These are the primitive data structure like integer, float, character and pointer. These are also as the data types for the particular programming language. But our major concern is for the non-primitive data structure. Whatever in this syllabus, in this course we will learn about the non-primitive data structure. So, various non-primitive data structures are classified in further into category. First one is the linear data structure, second one is the non-linear data structure. So, array, linked list, stack and queue. These are the example of linear data structure. Actually, in case of linear data structure are those data structure in which the data elements are stored in a linear manner. Okay, like elements are stored one after the other. Second type of non-primitive data structure is non-linear data structure. They don't follow any linear structure. They follow generally the hierarchical structure to store the data element. Like for example, graph and tree. These are two data structure which are the example of non-linear data structure. So, overall data structure is classified in two ways, linear and non-linear. In case of linear, array, linked list, stack and queue are there, and in case of non-linear, graph and tree are there. So, 1, 2, 3, 4, 5 and 6. In whole syllabus, we will study about these 6 data structure. These are the different type of operation operation we can perform on different data structure. First one is the create, insertion, deletion, searching, traverse and sorting. These are some operation that we can perform on a data structure. First one is the create. It means to how we declare or how we initialize a different type of data structure like array. Then how we can create a array, how we can create a linked list, how we can create a stack with 5 elements or a queue with 5 elements, how can we create a tree with binary search tree with 5 elements, 5 data elements. Okay, so create operation is basically used to create the data structure in which we can store the element. Second operation is insertion operation. Insertion operation is used to insert the element inside the data structure. Like what value we want to store in the data structure. So, to insert the value or to store the value inside the data structure, insertion operation is performed. Different types of algorithms are used for different data structure to perform the insertion operation. Like for example, for stack we use the push operation, and it used to uh, steps to insert the element in stack. Next one is the deletion operation. In case of deletion operation, basically used to remove an element from the existing data structure. Suppose in an array there are 10 elements, and we want to we want to delete an element from a particular index. Then how we can delete that element? So to delete an element, deletion operation is performed. Next one is the searching operation. If we want to presence of an data element in the array, whether suppose we have in the data structure, whether we have a data structure like array, stack and queue. Now we have to find whether the given element is present in that array or not. So for that purpose we have to search that data structure. So searching operation is used. Different type of searching techniques are available, like linear search, binary search. Okay. Next one is the traverse operation. Traverse operation is basically simply used to traverse a data structure. Like if there is an array which consists 10 element, then we have to print all the elements of array from index 0 to index 9. So traverse operation is basically used to visit each and every element stored in the data structure at least once. Okay. Next one is the sorting operation. We can sort the data element inside the data structure either in increasing order or decreasing order. So to perform sorting or to sort the elements of the data structure either in increasing or ascending or descending order, we perform the sorting operation. So these are some operations that we can perform on the different type of data structure. Next, first one is the array. What is array? Array is a collection of data element which are stored in consecutive memory location. Consecutive memory location means suppose if there is an element like this. This is an array which store 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 element. So this index will be 0. This is index is index 0, index 1, index 2, 3, similarly 4, 5, 6, 7, 8 and 9. So at index 0, 10 element is stored. So in case of array, the elements are stored in consecutive location. What does it means? If we have stored 10 at index 0, then next element will be stored at index 1. We cannot blank this index. It means we cannot store 12, we cannot leave it blank and store it on index 2. So before storing the element at index 2, it is compulsory that we have to store the element at index 1. So in this way, the array follow the consecutive memory location property. Okay, it means we cannot leave blank any index. In the last there may be a blank. Suppose this is an array of 10 size, then we can store suppose 7 element. These may be blank. In that case, there may be the 7 element, but these 7 element must be stored in consecutive memory location, one after the other. Okay. So this is the concept of array. This is just an example. In this way, the array is declared. First, we have to declare the data type. It means what type of value we want to store in data structure. Like for example, here it is int. It means we can store integer value. This is the array name and this is the maximum size of array. Okay. So to declare an array, first we need to specify the data type, then array name, then the size of array. So here this is an array of name ARR which can store maximum 10 data value and which those data value will be of integer type. In this way, we take the input of data elements of array from the computers. We will apply, suppose we have to store 10 element, then we will apply a loop, for loop from 0 to 9. Then we will take the input value with the help of scanf function. This is the syntax to print the data element. First from index 0 to index 9, we will simply print the data element. Okay. So this is the main thing, to accept the data elements input, and this is to print the data element. Next one is the linked list. Actually, to create the linked list, we need to learn about the pointer. So linked list is just like this. In case of linked list, different type of nodes are there. Linked list is a collection of nodes which are linked together with each other. Like this is a linked list which consists of 3 nodes: node 1, node 2 and node 3. And to implement this linked list, we have to use the pointer. So in case of linked list, every node consists of 2 parts. This is the first part of the node, this is second part of the node. First part of the node contains the data value, and second part of the node is a pointer which consists the address of next block in the linked list. It means it consists the address of N2. Similarly, here N2, this is the data field part, and this is the address field which consists the address of N3, and this is the last node. It means there is no next node after it. So the address field of node 3 consists the null. This cross represent the null. It means after this node there is no node in the linked list, or this is the last node of the linked list. Okay. So last of the address field of the last node of the linked list will consist the null. And again there is a head pointer, or it is also known as the start pointer, which will consist the address of the first node from where the linked list is started. Okay. So in case of linked list, the nodes are linked together, and node contains 2 parts. First part contains the data value, second part contains the address of the next node in the linked list, and the last node of the linked list, in case of last node of the linked list, the address field part will consist in null data value, which represent that this is the last node in the linked list. And again there is a separate pointer which consists the this is known as the head pointer or start pointer, which consists the address of the first node of the linked list. So this is general structure of the singly linked list or simple linked list. In case of doubly linked list, node consists 3 parts. Okay. Next one is the stack. Stack is a data structure in which the element can be retrieve, which work on the basis of the LIFO principle. It means the element which is inserted at the last, that will be retrieved first. So stack is a last in first out data structure. It follow the concept of last in first out. It means if we have to remove the data element from the stack, then at first the element which is inserted in the last, that will be removed. After that the second last element will be removed, and so on. So stack again this is a linear data structure. We can implement the stack by the help of an array and by the help of the linked list. Both can be used to implement the stack. Okay, suppose we have a stack which consists of maximum 4 elements. So first element will store here 10, next element will store 11, 12 and 13. Now if we have to remove, then first 13 will be removed, then 12 will be removed, then this and this. In case of stack, there is a pointer which is known as the top in case of linked list. Otherwise we can simply refer the index at which the element will be inserted or deleted. So here top represent the index value at which we have to insert the data element in the index, or from which we have to remove the data element from the stack. Next one is the queue data structure. In case of queue, there are 2 ends. First is known as the front and second is known as the rear. Here front represent the end at which we have to insert the data element in the queue, and rear at which we have to remove the data element from the queue, and rear represent the index at which we have to insert the data element in the queue. Suppose this is a queue which can store 4 elements. This is second element. Now the next element will be inserted here. So this will be the rear and this will be the front. First element will be deleted from here. Okay. So front represent the index or position from which we have to remove the data element in the queue, and similarly rear represent the index in the queue or location in the queue at which we have to insert the data element in the queue. Okay, so front to implement the queue, we need two pointer. First one is the front and second one is the rear. At front we have to delete from front we will delete the data element, and at rear we will insert the data element like this. Next one is the tree. Tree is again a non-linear data structure. It means it doesn't follow the linear concept. To implement the tree, we can also use the pointer. Tree, in case of tree, the elements are stored in hierarchical manner. So this is a general tree. This is the topmost element of the tree, and it is also known as the root. This is the left subtree, and this is the right subtree. Okay, so this is label 0, this is label 1, and this is label 2. So in case of tree, the data elements or data value are stored in hierarchical manner according to the label wise. So this again there may be different types of tree like binary search tree, ABL tree. We will see all those type of tree later in tree unit. So tree is what? Tree is generally a non-linear data structure in which data elements are stored in hierarchical manner according to the label wise, and there is only one topmost element which is known as the root node, and this is the left subtree of the root, and this is the right subtree for the root. Again, we can perform the search operation, we can perform the insert operation, we can perform the delete operation on the tree for different type of tree like binary search tree, ABL tree, and every a specific type of tree use different algorithm to insert or remove the element from the tree. Next one is the graph. Graph is again a non-linear data structure. In graph, basically there are two things. Graph is basically used to represent the network. Graph consists of two things. First thing is known as the vertex, and second one is the edge. Okay, so graph is a combination of vertex and edges, and vertex represent the data value or data element or data item to be stored. For example, this is a graph. In this graph, there are 5 vertices. Okay, and this is a directed graph, and these are the edges, and every edge has a label. A label is assigned, numeric value is assigned to every edge. So this value is known as the weight of that particular edge. So the edge which connect vertex V1 to vertex V2, weight of that edge is 10. Similarly, the edge which connect to vertex V2 and V5, edge of that weight is 6. So this is the directed weighted graph. This is undirected graph, and this is not a weighted graph. So here this is undirected graph. In case of undirected graph, there is no direction of the edge. Okay, it means this is edge can be read either from V1 to V3 or from V3 to V1. In the same way, this edge can be read either from V1 to V2 or from V2 to V1. It means in case of non-directed graph, the edge is y-directional. Edge is considered on the both side. Whereas in case of directed graph, edge is unidirectional. It means this edge is from B2 to B5. We cannot read it from B5 to B2 because this is a directed graph. So this arrow represents the direction of the edge. Okay. So it means in this graph there is a B2 is directly connected to B5. B5 is, it means B5 is directly reachable to B2, but B2 is not directly reachable from B5 because there is no direct edge from B5 to B2. Okay, so in case of directed graph, edge is unidirectional, and in case of undirected graph, edge is considered as the bidirectional. Different types of applications are there for each type of data structure. For example, Google Map. Google Map, to implement the Google Map graph is used. Social media network, again graph is used. So every data structure has its real-time real world application, can be used to solve the problem of a real world application. So these are our different type of data structure. So in this lecture, we have learned about the data structures introduction and different type of data structure. Again, I will summarize. There are 4 data structure which comes into the category of linear data structure, like array, stack, queue, and linked list. And 2 data structure are non-linear, like graph and tree. And each data structure can be used in different types of application or to solve the different type of real world problem.